Okay, so where we last left off, I had all of the cylinder heads prepped and ready for installation, valves shimmed and reinstalled, lapped them, all that good stuff. Where we're picking up now, I am getting ready to reinstall cylinder head number 1. Just going to quickly show you the little things to do there, and then I need to move on to some other stuff. I still have some parts for this that need to be painted. All of the rocker cages, rocker boxes, whatever you want to call them, those are all still dull castings right now, so I need to prime them, get some high temperature silver on them, and then I need to shim all of them. There's a whole procedure about how to properly install them because there are 3 studs up here and they're not all at the same heights and so on. As far as the cylinder head goes, all of the original copper gaskets have been annealed, and then I scrubbed off the oxidation with a piece of green Brillo pad, basically. The next thing that you do then is apply a coat of graphite paste to this. Now, the easiest place that I know to get it from is McMaster-Carr. This is Key Graphite Paste. This is the smallest container that they offer, and this is what is recommended by the club when you're putting this back together. I'm sure there are other places that make graphite paste, but that's what I'm working with. However, I am not using the included brush because it's huge and it tends to make a mess when you try to apply it to this small gasket here. So what I'm actually going to do is use an acid brush, and we're going to paint one side of this with the stuff here. You're not supposed to put it on real thick. There is a solvent in here that makes it easily spreadable, and then it dries out and leaves the graphite behind. Alright, that should be good enough. Now I am going to do this one edge here on the top before I put it on, because that side's going to be a little difficult to get to once I lay it on the top of the cylinder. I did initially try sliding these up the studs on the underside of the head before I just put them down in the cylinder, and that went well until I dropped one of these and had to get it off the floor, so it's probably just a safer bet to put it on first and then just slide the head over the gasket and cylinder assembly. Alright, that should be good enough. We can just kind of hook this on there. Some of these are a little snugger than others. I'm sure I didn't put them back exactly where they came off of. Not that it matters. Once it's been annealed, they're all soft enough to form to wherever they need to go. I'll probably have to. There we go. That looks pretty good. Freshly re-black oxided. These have actually been in a bag for weeks and weeks and weeks, so they did turn a little red, so I just applied some fresh oil to them to get them cleaned back up. It worked out just fine. And I've got brand new black oxide lock washers. I actually ran out on cylinder number 3, had to poke around in order to find a place that actually carries black oxide. Your big name stores, Lowe's, Home Depot, whatnot, do not stock that. It's Zinker, nothing else. However, we have Tacoma Screw Products here, and their main store did stock black oxide hardware, although a very limited selection, almost all metric. But the website also lists these M10 lock washers as being functionally equivalent to 3/8, which they're a little bigger than 3/8, but they are close enough. There we go. All right, let me just bring this up. There we go. Now it's just a matter of getting all of these started. guy back here. Is it kind of an awkward? My wrench doesn't quite want to spin. Don't think it's actually engaged with the threads any. I'm going to loosen the opposite side, lift the head up a little bit. Now I'm just going to snug these, get the head seated anyway. So I don't need to risk one of these studs pulling out of the head on me. Well, the long ones are highly unlikely to do that. The short ones, I've been warned, absolutely can and will. And I've been told that it's usually good practice to extract them and put in keenserts, or sorry, not keenserts, helicoils, to make the threads a little stronger. However, I was not able to extract any of the studs from these heads. I didn't want to put too much force on them. They were perfectly happy where they were. Okay, so that takes care of that. And for now, I will put the push rod tubes in place, mostly just to keep them off the floor. Alright, with the heads all reinstalled, there's one other thing I wanted to turn to before I start working on the valve cages and everything. I have a lot of small engine parts and steering components that I need to paint, and the paint that I'm using is a activated urethane enamel, and it only has like a 48-hour pot life, and I'm most likely not going to be able to use all of it with the parts that I do have. So I'm trying to find as many things as I can paint with it as possible. And the last two things that I have that I could potentially paint with this stuff are the generator and the starter motor. Now they do still have paint on them. It's not bad. It's a little dirty. But I do want to pull the generator anyway because I don't think it's been serviced in a long time. There's a lot of buildup of junk on the inside around the brushes. And also there's some electrical connections that are not going anywhere. This is actually the connection that goes to the cutout on top. I know the starter motor works, obviously. I flushed that out and took some paint off the inside of the end caps that were causing grounding problems. So I know that works well, but it does have two incorrect bolts holding it in. I need to find some more appropriate hardware, although those are a goofy thread size, unfortunately. First, we're just gonna take the nut off the top here and undo my negative battery cable. This is a positive ground vehicle. But I did put on some nicer original black oxide nuts on this. There we go. I've also been told to be careful removing the nuts from this stud here because it's actually soldered on the other end to one of the field coils for the starter, and if you reef on this too hard, you could break the solder joint and rip it right off that electrical connection, and that would be very unpleasant. Getting the field windings out of these starters or generators requires a special fixture to take those massive flathead screws out that I don't have and don't really want to mess with. So we're going to put all that back. These I'll probably just scuff them up real good. Probably not going to get too crazy. I don't think I'm going to blast them necessarily. That would be a lot of effort. But we will drop them. Okay, starter has 3 bolts that hold the unit onto the crankcase here. Got this one little guy right here that's a little awkward because the threads actually butt up into the motor mount. And then you've got this one here on the flange, and then there's another one at the very bottom. I've had this starter out quite a few times, actually. The extra flange business going on here is actually because this starter motor has a reduction gear drive bolted onto the end of it to give it the additional oomph necessary to spin this engine over. And it doesn't spin it very fast, but you don't need to spin it very fast. These are, a lot of these bolts are actually like Boeing surplus aircraft bolts that the previous owner collected up, figured he'd use on it. I mean, they do work, but they're really out of place on an engine like this. Boy, I shouldn't have to do too much here. This starter bolt has to be just a little shorter than all the others. I haven't been able to find one quite the right length. Might have to trim this one down to get it to work right. It doesn't seat fully. Okay, there we go. Now, ooh, there we go. That's a big boy. All right, that was the easy part. A little bit of... Oh, that's just discoloration. I thought that was oil all over it. No, it's just a little bit of junk. All right. Okay, now the generator. So the Franklin, like a lot of other cars of the period, has the generator being driven off of the timing chain. What makes this tricky is, and I don't know if this is the same for all cars, but the gear that actually has the chain attached to it, on the Franklin at least, is not directly connected to the generator. The generator shaft is splined on the end, and it slips into the gear, and the gear is supposed to be kept captive inside the front of the case here. There's actually a separate flange just ahead of the flange on the body of the generator that keeps all of that in line. And if we accidentally remove it, it will pop off of the generator sprocket and the chain will go limp and I will lose my timing setting. So we're going to try to avoid that. Like the starter motor, this is attached with 3 bolts, but we need to be cautious with the one on the bottom because it's doing double duty holding the flange in place. Let me just find, I believe those are 9/16. Yes. Also, this little tab of metal sticking up here, that's actually part of a mounting point for the sheet metal accessory that goes around the exhaust side of the engine to redirect the air. They call it an air deflector. Actually, apparently it became standard equipment 31 and later. But I do want to take this off because I need to check the insides. I'd like to bench test it a little if I can, make sure everything's okay. Make sure not to lose any of this. Okay, now before I take the other one off the top, we need to go underneath the engine here. Okay, so the lighting's not great. I don't actually have a flashlight handy, but we can see this nut right here is our lower retainer for the generator. This is actually a stud that is double-ended, so it is threaded, as far as I know, into the front of the crankcase, which is this lip right here. But we can see there is an additional silver piece sandwiched in between the flange of the crankcase and the flange of the generator. This guy right here, we want to leave in place because it's holding our generator sprocket and timing chain in place. So do not remove this front nut, only remove this one, and that should break us free, and we should be able to pull the generator out without upsetting anything. Ooh, okay, good. Flange is staying put. Ooh, breather tube back here is kind of in the way. Am I going to be able to navigate around that? Maybe? I don't know. Let me screw that back on there. That is really not in a good location, actually. I don't think I have to. I can't move this. It's pinned in place to the crank, or the crankcase. Oh, wait a minute. I think we might have gotten it. Let me see. Well, I certainly pushed something out of the way. I didn't feel one on the opposite side. It should have. Honestly, it just looks like they bored a hole through it. Nothing too crazy. Ooh. Just to move. Oh, look at that. Okay. Will that do it? Or did I just make things worse for myself? Maybe. Just maybe. Oh. Shoot. Well, I don't know. I suppose I can try. Yep, there we go. Okay, yeah, there was some motor oil trapped in the bottom there. So there's our spline. I'll need to wipe this whole thing down. So getting the generator apart is pretty easy. It literally just has a pair of very long bolts that pass through the end cap here. This is the rear end of the generator there. Got our oil flap for the one bearing that this generator has. Apparently the front end just gets supported by the sprocket off of the timing chain, which in turn runs on top of a aluminum casting. As far as I can tell, there isn't actually a true front bearing, just a smooth surface for the whole thing to ride on that gets flooded with engine oil when it's running. I'm sure that's perfectly fine. But yeah, once you take the bolts out, the front and back just kind of come apart, and the armature here actually came off with it because there is a nut on the end of it that captures it on that bearing in there. Take the nut off, then the whole end cap can come off here. That makes that pretty easy. I've already stripped the whole thing down. All the major parts are out. There's some work that needs to be done to this to get it ready for paint and reassembly. One of the things I did in preparation was I put the armature here in my mini lathe, which was just long enough to put it between centers, and I cleaned up the commutator here and then scrubbed all the junk out from in between the sections. It had a pretty good divot right in the center. It was dished, so that cleaned up pretty nicely. And overall, there's no damage in anything. None of the windings are coming apart, so that's all good. Nothing wrong with the end plate In fact, the 3 brushes that are in it appear to be the originals. That one right there still has the word Delco and Remy on it. They look like they've got enough meat on them for the while being. It's not like I'm going to drive this daily. And it should not be terribly difficult to get some replacement brushes should I need them. They're still being reproduced today. You can find them on eBay, for crying out loud. Now, the front casting, the front support casting for the generator did have some issues. There was actually a crack all the way around the left mounting ear, and I ground out probably a good 1/8 inch deep groove around the whole thing and then brazed it at work. This mounting ear had a slight crack that was going about halfway through from the back side. I ground that out and filled it just to be absolutely sure. And I did a little bit of shaping with some air tools and things. It's not perfect, the shape's not exactly the way it should, but it should remain pretty strong. And next time I'm going to be using flat washers on these ears when I reassemble it. There were lock washers underneath it which do not properly spread the load out, and we're putting pressure way too much on the center, and since those 2 front bolts are holding up the bulk of the weight there, they started to crack. So that's fixed. That's kind of prepped and ready for paint, already blasted it. The body of the generator, and if you're wondering, this is a model 957E, which seems to be pretty standard throughout all of the side draft engines. I don't think they bothered to change it. It might even be the same exact one they used on the V12s. On the whole, pretty good. Field windings, I checked them out. They ohm out just fine. There is a crossover wire. It's hard to see. Hang on. The field windings are joined in the middle, and there's a piece of friction tape wrapped wire right here. The friction tape has come apart at the ends, so I may remove this, unsolder the joint, put heat shrink over it, and seal that up a little better. But the main thing is the output wire that goes to the cutoff relay that lives on top of this thing. The insulation's totally shredded. So I need to get this apart, put new insulation on it. I want to try and save this because I don't have braided wire this size. And I'm reasonably certain that I can unsolder these connections here and hopefully get it back together. I may have to use a torch. And I'm also pretty sure this little stud that's right there should be a non-conductive material. I need to check that with a meter to make absolutely sure, but I'm reasonably positive. Now, I'm used to working on newer, like 50s and 60s charging systems that have voltage regulators. This is from 1930. Voltage regulation apparently didn't start to become common until the mid to late 30s. And then eventually current regulation was also added. So this system is more or less all or nothing. At idle, the generator isn't charging at all. Once you get enough speed up, I think the manual states about 25 miles per hour. Of course, they don't list an RPM, so I can't tell you exactly. Once that's high enough, it'll start charging. And there's a relay that lives on top of this guy that is purely intended to keep the battery from backfeeding the generator when the output of this is at lower potential than the battery voltage. If it were allowed to just connect straight through, this thing would motor and probably cook itself because the battery can supply several hundred amps through these little windings, whereas the generator can really only pump out, I think, 21 amps max when it's cold. Hang on, I have a datasheet for this. Yeah, so this isn't official data from Franklin, but they do specify that on a cold test, this thing can output 21 amps at about 1800 RPM, and it looks like the output voltage is somewhere in the neighborhood of 8.4 to 8.6, but once it warms up, let's see, hot test voltage, that drops to about 11 to 14 amps and about 7.5 to 7.8 volts. Again, closer to 1900 to 2100 RPM. So you gotta up the speed a little bit to get a consistent output, I guess. So that's the thing about these non-regulated systems, is they are either max output or nothing. And that's they can be a little hard on batteries. Of course, at the time you were checking them fairly often. You could top up the water. Modern batteries are sealed. It's a little harder on them. So the nice thing is you can actually set the output. The whole reason why there's a third brush in here is because it moves. Sorry, the bearing keeps wanting to come out. The third brush actually has a clamp right here. I've already loosened it. And this guy right here is mounted on a ring, and it will try to escape on me if I'm not careful. It will move between two posts cast into the base here. And this, I believe, should be connected back to the field windings. So you're basically changing how much current is flowing through the field windings, and that changes the strength of the field and thus the output current. Something along those lines. I haven't played with third brush systems at all, so this is all new territory for me. But that's how you alter what the normal output current is when it's running. What you're supposed to do is, with the engine running and with the system on, turn all of the accessories on you would use normally, all the lights, whatever, and then you would adjust the third brush to null out the ammeter. So bring it up to 0 amps, so that the generator is supplying all the possible electrical load, ignition included, that the car is expecting to use for normal running. Of course, the headlights are usually not on during the day, which means if you set it up with all the lights on for your night driving, it will have a nice nominal charge at night, but then during the day, the battery is going to get boiled. So for most people driving the cars now, the recommendation is to set this thing for daytime only driving. Night's kind of not something you're going to be doing in an automobile this old. My plan is to use all LED lights in the headlights and the marker lights and everything, which means this won't need to output quite as much, just barely enough to cover the ignition circuit, really. But yeah, basically I'll just set it up for daytime driving. I will probably set it up so that the headlights are on during the day for safety reasons, and to ensure that if they do run them with them off, that the battery does actually get some charge. Now, the Optima Red Top I'm using, I don't know how these vent pressure. I've heard some people say you can't use them with third brush non-regulated systems, whereas a whole bunch of other people say it's perfectly fine. Well, I'll see what happens. I'm just going to err on the side of caution and make it so that it's not cranking out more than is absolutely necessary for a few light accessories. There are two other little features that this thing has because we're not regulating the output voltage or current. We have a thermal overload thing. It's basically a bimetallic strip here with a set of points. This is actually the ground path for the field coil, for the field windings. This actually bolts, sorry, I took this apart earlier. This bolts up in here, something like that. And one of the field winding connections attaches right there, and this is how it grounds. So the other end winds up going to the third brush. This end is supposed to ground to the body of the generator. But if you notice, it doesn't do that. We've got insulating wafers of phenolic in there, and then we've got this power resistor. Should the generator get way too hot, either from the engine heat or from it pulling way too much current, this gap will pop open, and the current for the field windings will instead be bypassed through this power resistor. And this will choke the current, and it will limit the generator to a max output of, what do they say? Let's see. It's got a shunt field and thermostat. Let's see. Okay, so the thermostat's supposed to open at about 190 degrees Fahrenheit, and reduces the output of the generator by about 40%. Okay. With standard car setting, maximum charging rate is 18 amps at 8.6 volts. Reached about 1700 RPM or 27 miles per hour. Well, now, when they say 27 miles per hour, they're referring, as far as I can tell, they're referring to the engine speed coming out of the, well, measured at the flywheel, because with the transmission in high gear, it's a 1-to-1 output ratio. Every time I find engine speed listed in the Franklin books, they reference it in miles per hour and not RPM, so I'm reasonably sure they're not measuring it at the wheels, which would maybe be a little silly. So anyway, that mounts in there, but in order for this to ground to the body, we need another element. So there's a flat spot right here, this tab sticking up. I didn't realize that was for, because when I got the generator out, there was just this hole right there. So this lives just right about there. That hole is actually for the fuse. So not only do we have a thermostatic current regulator, but we also have a standard, well, it's not a standard 3AG cartridge fuse, but it is a glass cartridge fuse. There's a spring inside this little knurled booger. This fuse holder threads into this one specific hole right here, and one end of the fuse butts up inside of it, the other end of the fuse butts up against this flat spot, and that completes the field winding circuit. That fuse is apparently supposed to be rated at 6 amps. They no longer make 6 amp fuses in this size. However, 5 amp fuses are apparently available, and the Franklin Club members say that those work just fine. All that aside, really all I need to do at this point is get the rest of this cleaned up, fix the insulation, and then clean the old paint and grime up a little bit in preparation for a respray. Oh, and there is actually a gasket. I was confused by this. There is a gasket on both sides of the aluminum mounting plate that this bolts to. This is the one that actually fits on the front of this guy here. I need to make a new one. Fairly thin. I was confused by this because the generator has to ground to the engine in order to charge the battery, obviously, so the fact that they have a piece of paper in between there is a little odd, which means that a lot of the current's going to have to go through the mounting ear bolts, and maybe the center section might have electrical contact, and the gears on the generator probably do as well, so it's an unusual choice, but I'm sure they did that to keep the oil from the engine coming into here. In fact, the front of the generator has these, it's not quite a labyrinth seal like the front of the engine has on the back of the fan hub, but I suspect those are probably grooves to keep the oil from getting in and coating the inside of the generator. So with that part out of the way, the other thing I wanted to talk about, actually I don't know if we're going to talk about that right now. I wanted to talk about the distributor, but maybe we'll do that another time. There are some details that I need to take care of first. So instead, why don't we go back to the valve train system, because I have all the parts ready to reinstall and get the valve cages done. So with the starter motor and generator pulled out and out of the way, I decided to focus my attention on more reassembly. We'll get back to the two of those a little later. I wanted to get all of the rocker cages reinstalled. I'm running out of room with clean parts stacking up on the shelves, so I wanted to get everything back together as quickly as I could. Anyway, we're going to take a look at what it takes to actually put one of these back on there, including getting generating here. The first 5 are already in, number 6 is all that remains, and these are a little fiddly. So unlike most overhead valve engines where the rockers are actually part of the head, there's a separate iron casting here that holds these, and the valves of course are integral to the head itself. These simply slip over the top on 3 studs. These 3 studs, there's one back on the inside, are very long and are actually main head studs that go all the way down and are threaded on the opposite end for mounting the head of the cylinder. So they're pulling double duty. They're probably 8 inches long or so. Anyway, the front 2 obviously hold the cage. The rear, however, is called the compensating stud. The idea behind it, and the engineers that came up with it are probably definitely smarter than I am. The idea is this is supposed to compensate for the thermal expansion of the valve stems. So normally you have a cold setting for valves, at least in most cars they give you a cold setting. A few thousandths of an inch, I think it's about 7 thousandths on these when they're cold, or at least for 1930 it was. As the engine heats up and these get up to operating temperature, the valve stems will expand ever so slightly, and it will take up that gap to the point where the the head of the rocker here is actually almost in permanent contact with the valve stem. And if they're not adjusted right, they can actually hold them open at high RPMs. The valves will float instead of fully closing up and sealing, which is partially why they recommended shimming the springs to get them back up to proper tension so that under load they'll actually close up all the way. They'll have time to pull all the way closed. On most cars, though, once the engine warms up, they just expand, the gap is taken up, and the gap is simply there to account for the thermal expansion. Franklin came up with an interesting idea that this stud over here apparently is supposed to expand along with the cylinder head and the valve stems and everything. Once it gets hot, and like 500 degrees, that's what they claim these heads will get up to under operation, this stud will expand, press up on the valve, the rocker cage here, and apparently, or even all three of them, I'm not entirely sure, will lift the, they call them walking beams, they'll lift the rockers up and effectively maintain that gap as the engine heats up. At least that's what I understand. It's an interesting idea. Now, they've only got one stud here because obviously the casting for the rocker is eating up space on the other side. I imagine if they could have, they probably would have had two to balance things out, but we've only got the one to work with and then two attachment points on the front. Now the tops of these studs are shouldered. Take a look here. Sorry, I've actually tightened down the compensating stud here. This has to be extra long for easy access, and you can see how it wants to slouch back when it's not all torqued down. I've also removed the cork gasket. I was dry fitting everything because one of the problems you encounter is that the studs over the years tend to move around a little bit. So I'm sure when this was brand new, the face on these studs, there's a larger diameter face here, would have come in direct contact with these surfaces on the bottom of the rocker cage. However, over tightening, these studs, as far as I can tell, are simply press fit into the aluminum cylinder head. And as you torque them, as it heat cycles, they pull and they move, basically they move up and down. So these three studs right here are most likely no longer square to each other. They're no longer square to this casting. I don't even know if this casting is square to itself. And that can cause problems. The gentlemen in the club note that if this stud and these other two studs are not properly square with each other, the rockers won't be square with the valves, and it can cause issues over time. Maybe nothing catastrophic, but I imagine that if it's not set up right, it could actually cause the rockers to lean and put side load on the valves instead of being directly perpendicular to them and pushing the load straight down. That could have put additional wear on the valve guides, I suppose. So the whole idea is just to eliminate wear and to keep everything true. But with three studs, that's a little tricky. So since these are all at most likely at different heights over the years, the solution is to shim them. I've actually already got a black oxide washer on this guy to help out with that, and I'm gonna try and do my best to show how I've been setting these up. There's different information on the Franklin website in their old back copies of the magazine, which can only be accessed if you're a member, unfortunately, but it's an excellent resource, and most of the time they just talk about tightening this thing down. They don't mention shimming. One of the guys that's been helping me work on this engine over the forum, who rebuilt my fan, Paul Fitzpatrick, talked about how you do need to shim these and the general procedure, and his go-to solution, since these are 5/16 studs, is just to buy a bunch of really, really cheap 5/16 plated washers. Because the cheap ones that he finds have a lot of variation in thickness, so you get a decent range to work with in case these studs are wildly different from each other. Unfortunately, all the ones that I have bought are within a thousandth of an inch of each other. There is practically no variation at all, so instead I've been rummaging through my junk drawer and I found some new black oxide washers I have. They're like 46 thousandths. The plated ones I have are like 60 thousandths, and then I've got some odds and ends to work with. So the first 5 went pretty smoothly, but what we're going to do is I've got one right here, and the reason I've got that there is because the cork gasket that fits over the valves here, this guy, well, we need to crush that, but it's not super compressible. And given how low these studs most likely sit now, if I try to tighten this down, I'm going to crush this a lot more than it wants to be. And these ears, there's not a lot of thickness there. It's pretty decent, it's an iron casting, but over time I don't want these ears to break off trying to fight and basically bend over the top of this gasket. I mean, you'd have to put a lot of force on it to get it to do that, but it doesn't take much, and vibration over time could cause it to fail. So we're going to try and get these at a point where it'll crush the gasket, but not absolutely murder it, and still provide it, make it level with everything else. So that washer right there is to simply bring up our reference point, because we want to tighten the compensating stud first. Now we also need, you can see back here, I have reinstalled my push rod tubes, and the push rods are in there simply as placeholders, so I don't forget where they go. The lower nuts on here have been run down all the way to the bottom of their travel, or at least as far as they'll go. And that will get them off of these two surfaces here, because there is a paper gasket, or in my case, a paper-rubber combination gasket that's going to go in here to help seal that up, top and bottom. So we need to get those out of the way. We're going to drop this over the top without the cork gasket. We're going to do a dry fit. And we're just going to see how far off this thing is from seating. Now you can see it wants to slouch over that side. We're going to take our compensating stud extended hex nut. We're going to install that and tighten it down gently. You don't want to put too much force on these. If you twist off the top of one of these studs, you are in deep trouble. You have to extract the whole damn thing out of the head and figure out how to make a new one and put one in there. I don't want to do that. Okay, so that's reasonably snug down there, and this is not going to wobble. So let's see how much gap we have up front here. Well, fortunately, that's the best I can do. I don't have a lot of room to work with here, but it's hard to see, but there is a very tiny gap on both of these studs, from the face of the stud there to the bottom of this casting. And what I'm going to try and do is take some of my washers here, and I'm just going to kind of snug them in under here and see if they fit in between that point easily or not. Okay, so the black oxide one will slip pretty easily, so that might not be quite enough. Over here, about the same there. Not feeling a lot of resistance on the top. Let's try one of the plated ones. Yeah, see that? I'm going to have to wedge it in there to get it to move, so that's going to be too tall. Let's try the other side here. I've had to use interesting combinations to get that to work. No. That's not scooting in there nicely. Let's try some of this reject hardware I have laying around. Some of these actually, I should have kept the ones that came off of these. That was a bad move. I figured it'd be easy to swap them out. Not a bad fit over there. Let's try this side. Minorly tight fit on that side. Okay. So that it feels not so bad. I'm gonna measure these real quick. Alright, this old thing is about 49 thousandths. Our other black oxide friend's about 46. I'm gonna say the black oxide in this corner will probably work okay. It's got a little bit of friction, so it's making contact with both faces. It's not perfect. It's probably a few thou off from being perfect, but I am okay with that because I don't really have the setup to make brand new spacers here. My parting tool is completely dull, and I'd have to make them out of something like brass. I don't know if they'd be able to stand up to that much crushing force. So I think what we're going to do is we're going to try that one there, and then this decrepit old one on that stud there. And we'll just see if this sits somewhat happily. Now we're not going to put nuts on and tighten the front ones. We're just going to tighten this guy. All right. Then I'm going to take a flat blade screwdriver and I'm going to nudge. All right, that one's loose. This one is also somewhat loose. How much force would I need to put up here to get that to not move? Okay. Well, it's not terrible. It's not perfect. But that might be the best I can do under the circumstances. I do have one of these that's 54 thou. Let's see, how bad is this over here? Tell you what, I'll get back to you in just a moment. Okay, I think I've got the washer situation about where I want it. Here's what we... oh, god damn it. Wound up going with one of the black oxide in the back, some random washer I found here, and one of the new ones I found here. That seems to get me the closest I can possibly get. Very little force is required to get everything to seat. So I think that should do it. Now, we need to prep gaskets. I'll start with the cap that I just dropped on the floor. Start with the big cork guy here. This is a blue Hylamar. Everybody in the club swears by it. It's British, from what I understand, and it is rated for very high temperature use. But more importantly, it doesn't, supposedly, it doesn't dry. It's supposed to remain pliable, so if you use it on, I don't know, a pan gasket, you should be able to pull it off, clean it down with acetone, and then reuse it if need be. So, I'm just going to get a decent coating on here. This is all that prevents oil that collects around the valves from weeping out onto the rest of the cylinder head. This is, at best, just... I mean, it'll do something. It'll stop the worst of it, but it's not going to stop everything. But it should work pretty decently. Alright, that's pretty even. Now, we've got some gaskets that need to go around here. These little fellas. I had to make them myself because I forgot to order them with the rest of my gaskets. Oh well. It's just 1/32 gasket material. This stuff is supposedly oil-proof. It's a rubber paper mix of some kind, so it's relatively stiff, but it's got some decent flexibility, and it does seem to crush down pretty nicely, and rather than simply tear when you press a fastener up against it. And we're going to put one there, and I kind of forgot to finish cutting out the other one from my gasket material, so I'll quickly do that. And make sure these nuts are run down as far as they can go so it doesn't contact the bottom of the rocker cage when we fit it on there loosely. So on we go. Suffice to say, these do need to be nice and clean on the surfaces when you start. Since I already did mine, they should be okay. And yes, I painted the whole thing. Didn't mask off the inside. I kind of already had done one when I realized my mistake and decided to just go with it. It should be fine. I do wipe the paint out of the inside of the rocker pin holes so that the pins slide in a little easier, but I don't feel like it's that big of a deal. And we've got all this original hardware cleaned and re-black oxided for good measure. And we're going to snug up the compensating stud first, make sure it's flat. It is going to be trying to crush the gasket as we do this. Alright, here we go. Now, oh yeah, these unfortunately are an old size that is no longer common. I don't actually know what it is. I can't exactly remember. Oops, sorry. So the size I can't remember is actually 19/32. Apparently it was a very common size for heavy hex nuts for 5/16 studs. However, it is by no means common anymore today. The new standard for 5/16 heavy nuts is actually a 9/16 hex. However, if you do run across equipment that uses this old size, a 15mm wrench fits quite nicely. Still on the hunt for an original 19/32 wrench, though. Would be nice to have. Okay, how are we looking? More or less seated over there. That feels okay. Try and get a little bit of force on that one. Make sure this is tight still. Yep. Okay. And we've crushed down on the gasket. Excellent. All right, now we need to go to the other side of things. All right, now earlier, it's hard to see, I backed these nuts off. We are now going to carefully try to move them up. I spent a lot of time cleaning these threads to get these things to rotate without too much trouble, as getting wrenches into this space is near impossible. They are 7/8 in diameter. In fact, most folks recommend the use of pliers to tighten them. And we're not trying to actually put a whole lot of tension on these. If we push them up too much, it'll take load off the compensating stud and it'll throw everything off. We just want to put, I'm trying to just put a little bit of squish on the gasket to make it so that the push rod tube doesn't move a whole lot, because push rod tube needs to stay nice and vertical so that the top of the push rod stays centered on the rocker adjusting stud. If we don't do that, it might wear unevenly, or I don't know, put a side load on it. Now you're supposed to be able to do these with your fingers. That's kind of wishful thinking here. I'm not even sure I can do it really with my pliers. Yeah, it's not gonna work. Let me see. Not that I think that'll make a hell of a difference. Well, the gasket's not moving. That might be enough. How much play do we have? Yeah, that might be okay. In the meantime, we cut out the other gaskets. Okay. Here are our two upper gaskets. Now we just need the last two upper nuts. Now I had to run a tap through these things. A lot of them had some issues and they just refused to thread onto anything. That should squish down nicely. Alright, and let's see, this little guy should. Look at that. No trouble at all. Tell you what, getting these apart was a lot less fun. And now, let's put a little bit of gentle pressure. Just enough to ensure that stays where it ought to be. Almost forgot. Technically, I'm supposed to tighten this first. This is the pushrod tube retainer. It keeps them from spinning. Thankfully, there was enough grip down here that this didn't actually need to be tight for it to work. Also, if you've seen where my regular 11/16 box wrench went, I'd love to know, because it's not in the toolbox where it belongs. There we are. Okay. Pushrod tubes are mobile. Our nuts are installed. And this is where we're at. We are ready to put the rocker assemblies back in. I need to locate some new sets of pin retaining screws, however. I had one that was snapped off in here, and 3 that had damaged screw heads, one of which was completely broken off. Thankfully, the heads, cylinders, and valve cages from the original, or either it's, well, actually I don't know where they're from. I think they're off of the 33 engine. I still have all the valve train components, including all the set screws, so I'm going to rob the good ones off of that, clean them up, pop them in here. And I'll get back to you when I do that. Well, it's been, well, I don't know, weeks, month. I don't remember how old the footage was when I last left off there, but the valve train is completely reassembled. I've also got the intake manifold in, but that's for another episode. Everything went together pretty nicely. I wound up tapping each of the castings here for the lock studs. They're 1032, I believe. Cleaned all those out so that they would screw in and out nicely. Replaced the 3 damaged ones with good pulls from the other set of valve cages that I have. And then removed the paint from the inside of each of these castings for the rocker pins. Everything's together, went nicely. Overall, cleaned up pretty good. The little adjustment screws in the back here for setting the valve lash, the ends on them have been pounded completely flat. I tried to true them up a little bit on my belt sander by giving them a bit more of a tapered end. They're supposed to have a rounded end. Ideally, I should have moved them in an arc rather than doing an angle. So I should regrind or resand and profile all of them again so that they have a nice smooth round contour, just like the ends here. That way, when it pushes up on there, the rocker maintains constant contact. Otherwise, with just a plain flat surface, my finger doesn't really work well for that analogy. Here, I've got better visual aids. If the top of the push rod is flat and the bottom of the adjustment screw is also flat, when we start to push up and the adjustment screw starts to pivot, it's going to go like that, and the edge of the push rod is going to be bearing on it. However, if we curve the top of the bottom of the adjustment screw, no matter where in the rocker's rotation, it should have a single point of contact all the way across and remain centered on the push rod. At least it should. What I did was basically put a tapered point on it, which isn't perfect. It's better than having it be pounded totally flat, but it's not as good as having a nice round edge. Not that hard to do. Some guys have used valve grinding equipment for that. But a bench belt sander and a cordless drill is what I wound up using. I just need to go back and put an arc on them rather than just holding them at an angle. But all that's back in. Valve timing for this is pretty simple. Bring it up to top dead center. Started at number 1 and worked my way back. The Franklin manual lists how to do each one purely based on watching the action of the valves. I basically just verify that each cylinder is at TDC compression stroke, and then set the lash in both the valves. Now, as far as the valve lash goes, it differs by year. For 1930, the ID tag on the firewall actually stipulates a cold setting of 7,000s for intake and exhaust, which is in direct contrast with 31 to 34, where 7,000s is the hot setting with the engine at full operating temperature. And you're also supposed to set the valves with the engine running. I mean, I guess you just shut the engine off, and once it's up to temperature, set it then. I don't know exactly why they claim you have to have the engine running to do the setting. Whatever. Either way, that's fine for a 1930 engine. However, while the car is a 1930, the block that this engine was built out of, and presumably the cam that's in it, is from a 33 engine. So the cam profile is a little different. Apparently they adjusted it to lessen valve train noise. I don't know if they just changed the shape of the cams. The throws should all be the same, I think. I can't say for sure that the 1930 settings would be appropriate for a 1933, 50% of a 1933 engine. So I took a look around, and hot settings are all I can really find. The 1930 is the only one that seems to actually list a cold setting for the valves. However, I did find some generic service data for 1930 Franklins, and I think it was just a generic 1930 to 1934 set of instructions for most of the cars with a 6-cylinder engine in it. And they state that you can get away with a cold setting of 36 thousandths. Now, my gauge set does not go to 36, it goes to 35. And like a moron, I included another 10 thousandths instead of another 1,000th when I set these valves. So I actually need to go back and redo all of them. But even if it's 46 thousandths, too loose is better than too tight. It might not develop as much power as it should, or run perfectly, but it should still run. I also did a little work on some of the old valve oiling system. Unfortunately, I don't have all the fittings, and a lot of the plumbing is either gone or damaged. You have these little drip pipes. Let me just bring you over here. These little guys, they're supposed to drizzle oil onto the pads that go over the rockers. This one's pretty badly bent. They are soldered into a flare fitting that then has a compression nut around it. I have the other pipes for it, but they're all busted, so I need to unsolder them, buy some more pipe, and redo all of them to print. Do I really need to? No, I'm going to wind up hand oiling pads anyway. But it's a matter of completeness, and also I'd kind of like all these ports to be closed, or at least just, I want it to be original as I can get it with what I have. So, it's mostly aesthetics. I really like the look of copper piping on our engines this early. It's just a very classy look to me. And then, of course, all of the T-fittings on the edge here. I'm missing the one for number 1. This is supposed to be a 90 with a compression ferrule that jams in the end of it. And I've got everything for the first 5, but for whatever reason, I only have an extra T for number 1. It should have a 90, and I don't know where it went, or why he has extras of these, some of which are actually crushed on the ends and are no good. So I have to hit up the guys in the Franklin Club, see if I can't find one of those, and then fabricate some little inchworm copper pipe joiners between each of the T's, and eventually the shake oiler, which mounts over on the firewall. I'm hesitant to mount the shake oiler, though, because the main body of it is die cast, and it is starting to crack around the mounting lugs. And it's pot metal, so I'm going to be cautious there. I might have to put some JB weld on it to strengthen it up, but it's mostly just going to be for aesthetics. There's also a great big metal shield that goes over the side of the engine that in 1930 was an accessory, but apparently was standard issue on 31 and later engines to direct the airflow down and out of the engine compartment instead of much of it getting blasted against the firewall and cooking the passenger side. For right now, I'm probably going to leave it off. It's not really necessary. And plus, it allows you to see the other side of the engine when you're at shows. So I think I'll show you how the valves are running now that we've got all this set up. I'm actually rather pleased with the amount of compression I've got. I did put a little oil in each of the cylinders and wipe down the walls for safety before I put the spark plugs and heads and all that back on. That's about as much as I can do before it starts to get painful. But we have very good compression, and it's very satisfying to hear the exhaust valves open and you get a nice little pop from the escaping gases. So the cylinder head gaskets appear to be sealing up pretty nicely too. So this should run pretty damn well. I mean, it ran well when I started with it, to be honest, but I didn't screw anything up putting it back together, so that is a win. And I think that's going to do it for now. I've got a whole bunch of hardware on the way from Restoration Supply Co. to finish putting together the exhaust manifolds. Unfortunately, I don't have enough of the original crown head bolts to do the exhaust. There were only like 2 remaining, and they're all different lengths. So I broke down and dropped $200 on hardware. They're not cheap. $7 is the cheapest ones you can buy, and I needed at least 10 of them. So next time we'll get into rebuilding all of that, as well as reassembling the generator and dealing with the ignition system. I had to do some stuff to the distributors, and there's some issues with the mounting on it that I need to take care of before we start this thing. But until then, thanks for sticking around. This was a long one, and I'll see you back at the workbench.